Okay, let me explain what is the major ions in the solutions. In first, A, 1.00 molar nitric acid. Nitric acid is a strong acid. It will dissociate completely in the solution. So therefore, the equation for the dissociation of the nitric acid is HNO3. It will dissociate in aqueous solution, will dissociate to proton, H plus, and nitrate ion, NO3 minus. Therefore, in this case, the major ions are proton H plus and nitrate minus. So to be rigorous, and we can see the H plus proton should exist as H3O plus hydronium. And do we have any other ions or non-major or minor ions? Okay, remember in this solution we have a strong electrolyte, a strong acid, nitric acid, and we also have what? Water. Is water a strong electrolyte, weak electrolyte, or non-electrolyte? Actually, water, as we remember, is weak electrolyte. So therefore, that means water will dissociate. Okay, because weak electrolyte will roll like this, will dissociate in H plus and OH minus. So therefore, from this information, we know that in this solution we also have OH minus hydroxide ion, but the concentration of OH minus is extremely low. It's very, very low that we will not consider it its concentration, right? And therefore it is not major ions. Okay, if you understand this part, then it will be much easier to do the following problems. Okay, now in the next case we have 1.00 molar beryllium hydroxide with a strong base, and this is ionic compound, therefore it is dissociated completely, and we have beryllium OH2 in solution. It dissociates completely to beryllium cation and OH minus. Okay, and in this case the major ions are first beryllium 2 plus and OH minus. Remember that we also have a lot of water in this solution, and water dissociate very lightly to H plus and OH minus because it is weak electrolyte. Therefore, the major ion we have are beryllium 2 plus, hydroxide minus, and then we also have very tiny bit of the proton H plus, and H plus is not major ions. Okay, now the concentration. In part A, the concentration of H plus is the same as its acid, 1.00 molar, so it is 1.00 molar. And the concentration of nitrate ions is the same, 1.00 molar. Because the ratio here, nitric acid is 1 mole to 1 mole proton, 1 mole of nitric acid dissociated to have 1 mole of the proton, 1 mole of nitrate ions. In the second case, the concentration of beryllium is the same as the solution. It is 1.00 molar, but the concentration of hydroxide is 2.00 molar. Because for 1 mole of beryllium hydroxide, we produce the dissociation of 1 mole of beryllium hydroxide. We have 1 mole of beryllium cation, but 2 mole of hydroxide. Okay, now let's look at a more complicated case when nitric acid react with barium hydroxide. We have barium nitrate and water. Okay, this is the reactions. So from the concentration information, volume and concentration, we have the mole number for nitric acid, 2.00 mole, and 1.00 mole of barium hydroxide. So let's use initial, change, and final table, 0 mole. And keep in mind, this is in a water solution. We have a lot of water, so we don't care, we don't think too much about the water as a product. So it turned out there's no limiting reagent here. They reacted completely. So therefore, we have all 2 mole of nitric acid reacted, all the mole of the barium hydroxide reacted, and we have 1.00 mole of barium nitrate produced. At the final, we have 0 mole of initial acid, 0 mole of initial base, and 1.00 mole of barium nitrate. So we have 0 mole of acid, 0 mole of base. We don't think too much about water because water is a weak electrolyte, and we only have barium nitrate. So it is ionic compound, it's a strong electrolyte. It dissociates into barium and nitrate. So therefore we have 2 major ions, barium 2 plus, nitrate minus, and the concentration for them will be the mole number of each species over the volume. 2 liter plus 1 liter is 3 liters. So let's do it. Or we can see the concentration of barium nitrate is 1.00 mole over 3.00 liter. It is 0.333 molar. So there the concentration of barium is also 0.333 molar, but the concentration of nitrate, it is 2 times 0.333 molar, that is 0.66 molar. Now let's look at the other 2 scenarios when either of this acid or base is the limiting rate. Okay, in D we have 1 liter of 1 molar of nitric acid, strong acid, 1 liter of 1 molar of barium hydroxide. And let's write down the equation, reactions, and look at which one is limiting reagent. So we have 2HNO reacts barium OH, 2, we have barium NO3, 2 plus 2H2O liquid. And the mole number, we have 1.0 mole of nitric acid, 0.00 mole of barium hydroxide. Now barium hydroxide, yes, and 0 mole of product at the beginning. And in this case, you can figure out yourself that nitric acid is the limiting reagent and will be consumed completely, and the barium hydroxide is excess reagent and will have something remaining. So it will have 1 mole of nitric acid reacted completely and 0.500 mole of barium hydroxide consumed, and will produce 0.500 mole of barium nitrate. And the final, we have 0 mole of acid we have 0.500 mole of barium hydroxide, 0.500 mole of barium nitrate. So we have product 1, we have the barium hydroxide, barium nitrate, and water in the final solution. So what are the major ions? So from barium hydroxide, we have barium 2 plus hydroxide minus. From barium nitrate, we have barium 2 plus nitrate minus. And what is weak electrolyte? So we don't consider the proton H plus and OH minus from water. So therefore, we have 3 major ions: barium 2 plus, they are the same, hydroxide minus, and nitrate minus. So what are the concentration of these 3 major ions? So the concentration of barium hydroxide is 0.500 mole over the volume, total volume, 2.00 liter. It is 0.250 molar. And concentration of barium nitrate is 0.500 mole over 2.00 liter. That is 0.250 molar. So the concentration first of barium 2 plus will be the concentration of barium in this part plus the concentration of barium from this part. So therefore, the total concentration of the barium in the final solution is 0.250 molar plus 0.25 molar. It is 0.500 molar. And the concentration of hydroxide iodine, it is 0.250 molar right here, but 1 mole of barium hydroxide gave 2 mole of hydroxide. So therefore, the mole number, the concentration of hydroxide is this times 2. It is also 0.500 molar. And the concentration of nitrate here is this concentration of the barium nitrate times 2, because 1 mole of barium nitrate produces 2 mole of nitrate. So therefore, it is 0.50 molar times 2 gives 0.500 molar. So it happened to be all 3 major ions had the same concentration. It's purely by accident. I didn't mean to make it this way. Alright, so the last case, that 2 liter of 1 molar of the nitric acid is mixed with the 0.5 liter of 1.00 molar of barium hydroxide. The same reactions. HNO3 in aqueous solution, barium OH minus. In aqueous solution, we have barium nitrate and water. And initially, we have 2.00 mole of nitric acid and 0.50 mole of barium hydroxide and 0 mole of barium nitrate. And in this case, the barium hydroxide is the limiting reagent. So therefore, the change it is 0.50 mole barium hydroxide. It will reduce 1.0 mole of hydrogen nitric acid, and it will produce 0.50 mole of barium nitrate. And the final, sorry about messed up with the sig figures here. It'll be better we have a 3 sig figures. So let's assume we have a 3 sig figures to make things easier. That we have a 3 sig figures, 3 sig figures, 3 sig figures. So at the final, we have 1.00 mole of nitric acid remaining, 0.00 mole of barium hydroxide remaining, and 0.500 mole of barium nitrate remaining. And in the final solution, we have a strong acid, and as ionic compounds, beryllium nitrate remaining, no beryllium hydroxide. So what are the major ions? We know this is strong acid, therefore it's a strong electrolyte, so we have a H plus and nitrate cation. And from beryllium nitrate, it is ionic compounds, also a strong electrolyte, so we have a beryllium 2 plus and a nitrate minus. So therefore we have three major ions, that H plus, nitrate ion, and beryllium 2 plus. And we have a tiny bit of H minus from water dissociation, but that is not major ions. So how about the concentration of the major ions? First, the concentration of the excess reagent, nitric acid, is 1.000 mole over 2.500 liter, that is 0.400 molar. And the concentration of beryllium nitrate is 0.500 mole over 2.50 liter, that is 0.200 molar. So again, I'm sorry for messing up with the six figures here. So the concentration of the three major ions, first H plus, that is from the dissociation of the nitric acid, that is 0.400 molar. The second, nitrate has two parts. One is from nitric acid, and another part is from beryllium nitrate. So therefore the final concentration of nitrate ion is 0.400 molar. This part is from nitric acid, and 0.200 molar times 2, because for 1 mole of beryllium nitrate we have 2 mole of nitrate ions produced. Therefore the final concentration for nitrate is 0.800 molar. And the concentration for beryllium, that is solely from beryllium nitrate, that we have 0.200 molar. Okay.